Previously in this course, I have discussed what are known as descriptive statistics. Descriptive statistics, as the name implies, provide facts about your data. Those can include measures such as medians, means, variance, and standard deviation. You can then use these facts about your data to make estimates at a known confidence level. For example, you might think that most of your customers live within a 25-mile radius, plus or minus 3 or 4 miles. And you might be wondering, what else is there? It turns out there's a lot more. Let me give you an example. Let's assume, for the sake of argument, that you might have the flu, and your test for the flu has come back positive. The test has the following characteristics, and all of these will be important for our analysis. It returns the correct result 85% of the time. It identifies healthy individuals as having the flu 10% of the time. So in other words, if you do have the flu, you will get a positive result 85% of the time, a negative result 15% of the time. If you don't have the flu, then you'll get a positive result 10% of the time, a false positive, and you'll get the correct result of negative the other 90%. We also have a base rate, which assumes that about 1% of the population actually has the flu at the time you take the test. So the question is, what is the probability that you actually have the flu? For this, we use Bayes' rule. We combine the accuracy, false positive, and base rate to find the result. So if 1% of the population has the flu, and the test is 85% accurate, but there's also a 10% false positive rate, a positive test means the probability that you actually have the flu is 7.91%. How we got to that number is the subject of the rest of this chapter.